I'm not sure if I'm audible. I hope I'm audible. GPUs for today. I did a Windows update and like my GPU is not working. Like yeah, whatever. Never do a Windows update before an important work. It's like GPU is not getting registered for some reason. Kind of fucked. Wait, let me activate the display capture video capture device. Is this it? Yes, bro. Nothing is working today. Okay, why are you not working, buddy? Yeah, I want to delete it. Video. Yep. Integrated camera, no, give me the Logitech. Okay. It's not working. What about this one? Yeah, this will do, I guess. We'll have to do. Let me put it. Video capture device. Oh, such a nuisance. So what I'm gonna discuss today is differential geometry. Where's my notebook? Why do we need differential geometry? Why do we care? And how it helps us? So what differential geometry is? We use calculus to define geometry, and like we do a bunch of shit with that, and that's differential geometry, I guess. Why do we care? If you have used Blender or any 3D modeling software, so if you like unwrap textures, like what is a texture? Texture is like the surface, like texture is like a map wrapped around the surface. Alright, so like this is the mouse, then this entire colored this black color, and like how the designs are, like imagine this on a sheet of paper and being wrapped around it. That's basically is Adnan. Oh yeah, bro, I don't know. Well, glad to have someone finally on the stream, but if I know you from somewhere, please do mention. Yeah, so that's texture is, and like so if you are wrapping texture, well, what an artist has to do is just simply click some buttons and you get a texture, but the way it's being done behind the scenes, well, some programmer actually implemented how that would work, and to do that you need differential geometry, and that's why we care. Well, this is like a professor told us. How will you define this? Well, let me give you an easy example. Where's my eraser? Yep. How will you define this eraser shape? Well, you could call it a cuboid. Okay, that's pretty easy. How will you define a tree shape? Well, Adnan from Lane, yeah, I thought so, bro. I thought so. Yeah. Where are you from, bro? Are you a college student, or do you work somewhere? What do you do? Tell us about yourself, brother. So, that's how you so how will you define a tree? Like what shape it is, and that's where differential geometry comes in. You can define the shape of a tree or any arbitrary shape of a 3D object mathematically, and that's very helpful. We'll get into the maths today, so if you haven't seen calculus in quite some time, bro, or you have forgotten about it, or let's say you were not good with it like me, your brains are about to be fucked, and get ready for a brain fuck. Oh, by the way, Adnan, my friend, or anyone else who is watching, please tell me how is the bloody audio. Am I audible enough? Please let me know. Otherwise, I'm just jibber jabbing and for no fucking reason. No response. Well, I guess if I am inaudible, someone will mention that, I guess. Let's hope so. Well. To this scene. Okay. Yes, I'm watching myself. Is this a good wallpaper or not? How? What do you think? Is this a good? By the way, if you don't know where this wallpaper is from, you are not a true gamer. I don't know, go kill yourself or something. Open mode, yeah. Oh, why the fuck is it not working? Okay, no, bro, I don't want the setup. Fuck you. Huh? Try again. Open mode. Okay, what else do we need? We need some slides. Hamish's slides. By the way, wait. Let me tell you an interesting story. I just remembered. So before getting into this weird shit, let me tell you a sort of funny, maybe, I don't know, if you can have fun with that. So, potential. Last weekend I made palak paneer, and so while I was heating a butter on that kadhai, it was giving a lot of smoke. It was giving so much smoke, the entire kitchen was filled with it, and the fire alarms started going off. It was crazy. Flatmates were there, they were panicking. I wasn't I was zoned in. I was busy cooking, I didn't give a fuck. It was just smoke, and the fire alarms were going crazy. And then the security guy comes in and what happened? Yeah, he comes in panicking, some shit is something is up, and so he enters the kitchen and entire kitchen is full of smoke. and my flatmate tells him, "Oh, he's cooking some Indian food," and the guy just left, as if saying Indian food explained everything. So that was pretty crazy, and like my flatmates were saying, shouting, so like, stop, don't cook anymore. Like, fuck it. Hi, there's probably something wrong with the audio. The voice is cracking on my side. Oh fuck, yeah. Thank you for telling me. Oh, voice is cracking. Oh, and my GPU is not working, probably because of that. Fuck. Wait, let me see what can I do about this thing. Default, no. Please work, buddy, please. How's the audio now? Let me know. Hello, hello, mic test. 1 2 3 1 2 3 1 2 3 1 2 3. Come back home and cook for your family. Never. How's the audio? How's the audio? How's the audio? Now it's echoing. Ah, well, let me see if I can do something about it. NVIDIA broadcast, please. Nothing is working today. But is it audible? Are you able to make sense of what I'm trying to say? It's fine? Okay. Perfect. Display capture. Also, let me out the audio input capture. Yeah. I want the microphone. Yeah, give me this one. Yep. Am I audible now? Is it fine? Like right after this moment. Oh, you are able to make sense of my notes. Then that is fine. That's what we need. That's what we care about. Nothing else matters. That's what we care about. So, where was I? We were at differential geometry. So, to get to the 3D space, we first need to understand how do we define a curve. And this is where shit comes in. Where are the slides? Oh, differential geometry curves. I think this was it. Yup. This is it. Let me see. Yep. Okay. So, well, I'm gonna have to look at the slides because, well, I don't have these things by heart, but I can make sense of it. And that's the title of the stream. We are going to make sense of differential geometry. Oh, let me open my notes. Give me a second. Yeah. Well, where is the line? Oh, okay. Yep. Give me a short one. Yeah. Is it? Nah. So, this is a line. I mean, like graph. Say. One. Fuck. Why am I putting one there? 1, 2. Maybe I should get a tab. 3. Yeah, this should be fine. 1, 2, 3. Okay. How are you going to like define, let's say there's a function f of t equals to, oh damn, this sucks so much, f of t comma t. Well, shit man, oh it's so hard to write with the mouse. Fuck, I'll see if I can explain it on the slides itself. Fuck it. Okay, so how will you describe this? Wait, let me see if I can bring the board here. Desktop. Oh. Yup. No. Yeah. So this is the function f of t equals to t comma t. So you can see the line, it would be like oh come on bro, let me use it. Yeah, this would be a straight line like this. I mean, like you can see the one, the black, the thin line. How will you get this line? Well, you put like some random points, let t equals to 1, then you will get 1 comma 1, t equals to 2, you will get 2 comma 2, join the points, you get the bloody line. And g of t equals to t square comma t square. So in that case you will get the g line, and see if you can like notice that it starts from origin and goes towards the infinity, and you have no points on the negative side, because, well, if you put -1, let's say t equals to -1 squared comma -1 squared, that gives you, well, 1 comma 1. So like you won't get any negative numbers, so that's why it starts from origin and expands to infinity. Well, for t cube, if you notice, it's basically the same line as the f of ft, and the reason being because like if you put a positive number, you get a point on the f of t, and you put a negative number, you still get a point of the f of t. And like both of the same line defines these I mean, like this curve can be defined by these two, f of t, h of t. Since like there's no how do I put it, there's no specific way to define these two curves, so like we have to come up with something, because well, we have the multiple, as the slide says, we have the multiple versions representing the same curve, and we don't want that. So wait. Oh, this sucks so much. Fuck, I'm gonna close this board. Yeah, now it's better. Okay, so we are going to define arc length. Well, I'll have to tell you what arc length integral is. Well, okay, okay, so we will find like we have to find how far we have traveled along this curve with a constant speed 1, and that's basically the arc length parameterization. And okay, how you get this? How we get this equation? Where's the board? I think we need it. Open board. So, well, look at the definition. Like arc, to get the arc length parameterization, we have to like tell how far we have traveled along the curve at a constant speed 1. So I mean, like, if you look at this, yep, L of t. Oh no, I want the black color. So f of t is a function of t comma t at t comma t. Well then, f of, if we take a norm of this function, we get root over t square plus t square. Oh, I think it's easier to write it in bold. So we get 2 times of t square, which is root 2t. Now it says, like, we have to move along the curve at a constant speed 1, and root 2 is 1.41 something something something, which is greater than 1. So we are going too fast. So what we do is, like, we divide. So how do we get it to 1? So for that we just divide it by root 2. T by root 2. Wait, I should write it somewhere else. It's getting cluttered. Next page. How do you get to next page? Okay. Oh shit. Yep. So we divided by root 2 and we get t by root 2 comma t by root 2. And this is what we call as the arc length parameterization, and it if you take, like, and it is equal to 1. So, and then Hamish goes us to tell us the arc length integral. So, well, I can explain you why this f dash x. Okay, so this is, like, for us, this is a curve, okay, and we want to find this length of this dotted line. So how do we do that? So let's suppose, like, this is a small distance px, and this is the vector v, and we can find this. I can tell you, well, it would be, well, that's okay, alright. Let me tell you how we get that f dash x dx. Well, this is the vector v, and so if you notice that this is a small triangle right underneath that curve, and it's the property of the triangle. Well, you can simply get the hypotenuse, and hypotenuse equals to root over del x plus del y square. We are going to write it as dx and dy square. Come on. Okay, and then what we do is, like, fuck. Oh, this is so horrible. Maybe I should just start coding live. That would be better. Fuck, he's here. Yes, my friend, I'm here. I'm here. I'm glad you are here. By the way, I'm so sorry, bro, for the fucked up audio. What are you teaching, Acharya? Differential geometry, bro. You missed the starting part. I'm not going to repeat it. Well, let me just tell you that why are we doing it? Well, to define a surface mathematically, any arbitrary shape mathematically, and that's why are we doing this. Oh, smile emoji. By the way, is it audible? Are you able to make sense of the audio, my Dheeraj friend? I hope you are. Audio is okay. Just to mute my speaker. Audio is just okay. Just need to mute my speaker. Okay. Damn. Bro, what can I do, bro? My GPU is not working today. I did a Windows update and like my PC is not registering my GPU now. Like, fuck. What can I say now? Sucks. Okay, so yep, we multiply this by and divide by dy by dx square. Oh, come on, dy by dx. This is so hard to write, bro. And like if we are going to take dx common, so it just basically becomes dx root over 1 plus dy by dx square, and this is basically it. Wait, is that it? Yep. Root over this we get this function, and this is the length, and okay, what is it doing? Okay, we get this, we take the norm, we get this, and okay, yeah, so this is basically the speed, and we integrate the speed and we basically get the length. Okay, then define the ALP to be parameterization where parameter t is the length. What the fuck? Define the ALP to be the parameterization where parameter is t is the length. Okay, u equals to oh, this is the same thing, arc length parameterization. This double line is just taking the norm of the f dash t, which is this line, this part. There's always an ALP, it may not be easy to find. So yep, we found the we have the velocity, and since we have the velocity as a direction, and well, f dash norm of f dash u equals to 1, because since it's ALP, arc length parameterization, I already proved it to you, it will be 1, because that's why we divided it by root 2, so that it is 1. And for that stage here today? No. Okay, so we take a square root on both sides. No, we don't. substitute the definition of root norm of v. Okay, we get this, we square root this, and we do the partial derivatives. If you don't know the formula of partial derivative, well, this is it, f dash g plus g dash f. I think it was in 11th class calculus, 11th or 10th maybe, I don't know, but one of those. And since f dash u and f double dash u and f dash u are commutative, so we can directly write them as 2 times of f dash u and f dash u, and this is equals to 0. So the dot product between these two will only be 0 when they both are perpendicular. So like, this is the interesting part. Like, wait, is there a diagram for this? No? Oh yes, there is. Yes, there is. So this is the curve, and we found the velocity by integrating the length. And fuck, what the fuck am I saying? Yeah, we found this velocity f dash u, and like, if we further differentiate it, well, we get the acceleration f double dash u, and you have the how should I put this? Well, you have the velocity, you have the acceleration, which is at 90 degree. So if you have like two axes at 90 degrees, you can get the third axis by doing a cross product, and then you can create a orthogonal axis, and you can do a bunch of shit with an orthogonal axis, transformations and shit, and this orthogonal axis, like, it will always stay with the object locally. So if the object is rotating like this, or however along the curve, the orthogonal axis will change accordingly, and as long as you have this velocity and acceleration, you can find the third vector by doing a cross product, and you have the axis. Oh, this is good. So like, this was the ALP of y equals to x. The thing I did, this t by root 2, this equation, and if you like differentiate it, you get this, you differentiate it again, you get acceleration. And but what about if this is a circle? So in a circle, you will always get, like, if you take the norm of the equation, you will get 1. If you take velocity, you will get that 1. But like, provided the radius is 1, and you take the acceleration, I mean, like, doing a second derivative, you will still get 1. And how is that? Like, if you differentiate sine x, well, let me show you, it would make more sense, I guess. So wait, norm of fs, wait, let me write what fs is. Sine x cos x. So this is the equation of a circle. Oh damn. And if you take a norm of this, yeah, you get sine square theta plus cos square theta, which is basically 1. Now if you differentiate fs, you get, wait, what's the differentiation? I think it's negative cos x. I don't know. I mean, like, I think one of them is negative. Let me check. Derivative of sine x. shit, I don't remember this shit. Cos x, okay, then the cos x negative, I guess. Cos x, it's minus sin x, yeah. So sin x derive, if you did the derivative is cos x, and this is minus sin s. Damn. Now if you like take the norm of this function, which is basically your velocity or direction vector, you can also call it that, because the velocity always has a direction and magnitude, and like we care more about the direction. So it becomes like cos square x plus minus of sine, come on buddy, sine minus of minus of sine s square, and you put a root over it, and you still get 1. Now if you differentiate this function again, like cos s minus sine s, you will still, and like take the norm over it, you will still get 1. And that's what it basically says. And we call the acceleration like as the constant unit principal normal vector, since it's always equal to 1. That's why, I mean, like mathematicians came with this terminology, I don't know. Okay, okay, but what about like if the radius is 2? Well, if the radius is 2, well, the signs will, you will still get the positive signs everywhere, like after taking the norm. But if you plug 2 cos x and 2 sin x instead of sin x cos x, you will it will basically turn out to be 2. So what it means is like the magnitude has doubled, and like yeah, so basically you get a loser curve. Okay, so let me explain it to you what the concept of curve is. So this has a this circle was for this one, so it has a radius of 1, and this one has a radius of 2. So and like we found this principal normal vector, which is this acceleration. That's what we are calling it. So at any given point, like if you create a circle like which is tangent to it with such that its principal normal vectors, the magnitude of the principal normal vector is the radius of that circle, well, you can fit a circle there, and like, well, it is, Hamish told us it would be useful when we would be doing that, what's that thing? Mesh processing, yeah, mesh processing. So we haven't been told why this shit is useful, but we were just given the intuition of the same. Now going for stream, goodbye, bye. I'm also done with the stream, almost like maybe a couple of minutes more. Okay, so yeah, where was I? Once again. I know, this can be pretty boring. Yeah. But it is very necessary. See, I guess this was about the banking of the roads, like if there's very, how to put it, it's a very tight curve, like I mean, like when you're trying to turn, you want a loose curve, not a tight curve, but a tighter curve is sort of helpful when trying to work with meshes. And well, basically when you are doing mesh processing. And I don't know how much, how exactly it relates to that yet, because well, we haven't been told. But when I'll find out, I'll let you guys know, I guess. Actually, stuff is very hard to put until some writing on the board, and just explaining it with slides, it doesn't work. And this is why, like, when we are having these lectures on differential geometry, our professor is not bringing his own slides. I mean, like, he's constructing this slides live, is doing all the calculation, and we are following them live. He's doing it like on an iPad, and it is on the it is projected on the screen, and later he dumps it all onto a PDF. So that's why, like, I had this whiteboard ready, but it's so hard to write on this. I'm telling us like it's a tab, and I don't have a tab. Fuck. Parameter domain. Okay, I'll just cover this slide and maybe call it a day, I guess, because we don't have the necessary slides. We didn't upload it yet for to cover like how to like define surfaces. So maybe I'll just call it a day with the defining of curves, foundations of for this shit. So what does it say? So this is the surface which is mapped from r square to r cube, where r square, imagine r square to r cube. We are imagine that like this. Okay, this would make more sense. You must have seen a globe, and like globe and like the same map on a piece of paper. So the map is actually created from like the globe itself, but it is put on a piece of 2D paper, and like that's what it says, like mapping of a 2D surface to 3D, because like in video games that's what texture mapping is. You map a piece of 2D texture over a surface, and it makes things look pretty. So this was like mapping of do I have a piece of paper? It would make more sense. Yep. So like this is the piece of paper, and like if you take if you take these two edges and join them, that's like A, and if you like fuck, I can't fold it. I'm like, wait, if you bring these B edges and join them together, it basically forms a sort of donut. I don't know if you can see, but I hope you get the intuition. It forms a donut, and Yeah. So like, what the point? What the fuck the point is? Well, the point is, how will you like in a 3D model, let's say, which is a donut, how will you map 2D texture, which is like, well, all the textures are 2D, a piece of paper, and they get wrapped around the objects. So how that mapping will happen? That's what it's about. So for a donut, you could just uh, bring this AA side together and like glue it together, and then you have this two sides and you glue them together, and yeah, you get your donut. I mean, like, if you're using 3D modeling software, you just have to click buttons, tick 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 tick, and it gets all the, I mean, like, you can unwrap your textures or wrap or whatever, but someone needs to implement that functionality, and that's my bloody job, I guess. And that's why we have to make sense of how the mapping would be done and what are the things that would be required. Well, it's differential geometry. And then Hamish goes on. Well, I say Hamish a lot on this stream. Hamish is the name of our professor, so that's what we call him. And so he goes on to explain 1-point compactification, and so I don't know if you have seen this. If you ever been to like bowling, there's this rubber sheet kind of thing in which like you put your bowling ball and you clean it. So imagine that, like, this is a rubber sheet and there's a ball in it, and like, and how you like clean that, that's basically what the figure is showing. So if you take those two ends and like bring them, imagine the rubber sheet to be plain first, like this paper was. Well, it's not plain anymore. Wait, remove the pieces. So imagine this rubber sheet and like you put a spherical ball in it and you put it together, you bring it together, and like at the top you create a knot kind of thing. So like this knot is called 1-point compactification, and this is like one way to wrap a sphere, and the other way is like doing a 2-point compactification, which is basically like you put a sphere right in the middle of the paper, and like you form that tube first, and then you close from this end and this end. So you have two different 1-point compactification points, and it's called 2-point compactification. Yeah, weird shit. Well, I was going to make an interesting point. Yeah, do you know, like in a globe 3D, if you have seen a 3D globe model, and on a 2D world map, it is distorted. The map is actually, wait, yeah. If you try to like wrap that 2D map on that globe, it gets distorted at the poles, right? Try to imagine it, or like if you have a world map paper or piece of paper, right? Like if you would imagine like wrapping this paper around a sphere, well, it would get distorted at the north and the south poles, and we don't want that to be happening with our 3D models. And to avoid that, well, that's why we are studying differential geometry, to find better ways of doing that, so that weird shit doesn't happen. Ah, okay, so this was like take a square piece of paper and forget like this is a corner. Like if there were no corners. Let me see if I can show you. Oh, this is not a square piece of paper. It won't work. Wait. It's hard to show it from a piece of paper. Your imagination will have to do. I mean, like, if you bring um, this side and this side and like glue it together, so like this is one way of gluing, I guess. And dot donut, double donut, genus 2. Okay. Okay, this is like a hexagon, and like if you glue AA along PB along CC. Okay, this is what our professor told us. Don't try to imagine this one. So I'm not gonna ask you guys to imagine this one because it will fuck with your mind. Just take my word for it. This will literally form a donut. Yeah. No, I mean like, sorry. This will form a double donut. Yeah, I think he told us something else. Maybe I took it down in the notes. Wait. No, nothing. It was about something else. In practice, assume we have a set of patches pieces of R square and we have a way of gluing them together consistently. We can assume that we have an input manifold. Oh damn, there are people. Ashish Kumar, how many times you are going to use that piece of paper that you have thrown a kilometer away? Bro. Many times. Then, how are you, my friend? By the way, please get that thing working that I've told you, bro. Get that sorted out. Otherwise, things will go wrong. I'm just warning you. So, okay, where was I? In practice, assume we have a set of patches, pieces of R square. We have a way of gluing them together consistently. We can assume that we have an input manifold omega that is everywhere locally homomorphic to where this. Okay, I'll get to this, what this means actually. So, I mean, like, what he says basically here that just imagine that we have a bunch of patches, patches of those pieces of paper that we would wrap around our objects, and R square basically means like 2D surface. So when you see R square, imagine 2D. When you see R cube, imagine 3D. Actually, that's what I do, and it makes way more sense. Well, that's actually it is. So yeah, so we have a bunch of patches and we have a way of gluing together. When we just saw how we can glue in different ways, like if you glue it AA and BB, we can get a donut or a tire tube. And if you take a ball on a rubber sheet and just tie it on the top, like imagine a knot kind of thing, then we get a 1-point compactification. And if we take the same ball and put it in the middle of the paper and join these AA sides and then do a 1-point compactification at the edges, we get a 2-point compactification. Imagine a toffee, a clearest toffee. That's 2-point compactification. Angles of Arctic and Antarctic region trying in corner after the way you exchange the distortion of 2D to 3D mode. Bro, tell me, did any of that make sense? I mean, like, not in the way like mathematically, but did it give you intuition? Like, were you able to grasp or like the fuck I'm talking about? Like, some sort of idea or something. Hello, my friend, are you still there? Were you able to get some sort of intuition? Maybe he left. Fuck it. Okay. Yeah. So we have a bunch of, imagine we have a bunch of patches, like square paper hits again. So imagine like we have bunch of pieces of square paper, uh, and we have a way of gluing them together consistently. When we saw how we can glue in like multiple ways. If you like glue it along these arrows, you will get like some sort of how do I put this thing? There's no name to this shape, bro. I mean, like, yeah, you can imagine you will get something like this, and you can just glue it along that. I don't know. It's hard to tell. Yes, 1 point compactification. Oh, bro, understood 1 point compactification, bro. Damn. So, we just saw how we can glue a piece of 2D paper in multiple ways to wrap it around an object. And we can assume that we have an input manifold omega that is everywhere locally homomorphic toward us. Okay. Let me go through this again. We can assume that we have an input manifold omega that is okay. What does omega means? Well, it's just the parameter domain. I mean, like, we are talking about this piece of paper. It's, I'm saying it in very layman's terms, but like, yeah, imagine that we have an input manifold that is everywhere local homomorphic to us. So I mean, like, what this basically says, locally homomorphic, like, this will behave normally. There won't be any distortion, at least in this patch of this patch of paper. There won't be any distortion, and like we could like glue those individual patches to make the entire object. A surface is defined by a function omega is r cube. Okay, this will make more sense to you now. Surface is defined by a function omega to r cube. So what omega was like 2D, and r cube is like a 3D sphere, an arbitrary shape, and well, 2D is given by parameters like 2 u comma v, and like 3D you get x y z. So like, yeah, this is what it means like by the graph. Like, we are trying to map a 2D parameter domains. We are trying to map a curve in a 2D parameter domain to a 3D spatial domain, and this is the shit we will build on top of. I wish I had the slides for the next one, because now that is the main stuff. Now the real differential geometry starts. That was like the basic stuff that you need to know to get that. I mean, like, that this was us defining us what the curves are, and like how do you find the length of a curve, how do you define ACL, how to get an acceleration, and now we can build on top of that knowledge. Well, once we have defined it for a curve which is in 2D, now we can move towards 3D. But I don't have the slides for that. Shit. Wait, let me just think of something. Can it be done? Wait, let me just see what he just uploaded in the last 60 minutes. Let me refresh it. I'm not that lucky, but by the way, oh, so that's the teaser only. Yes, my friend, that's just the teaser. And after like there's like 2-3 hours of Tejas Rizwan, mother lover. Tejas is such a mother lover. Let me tell you about this guy. What he did. What he did. Bro, are you still here? Tej, are you still here? Please say something. Come on. Okay. So Tej is my batchmate. He's doing the same course. We are having the same classes and all. So Tej is here. Bro. Yes. I'm gonna tell these guys what you did, bro. He did the most medieval things you could do. I enter the class, okay, and like I'm sitting. I on that day I was about to go like sit on the in the second row, but that day for some reason I decided, okay, fuck it, let's sit on the third row. I don't know, and Tej was sitting right in the middle, and like I went and sat right next to him. And then Tej was like, after after I sat down like 2 minutes in the class, Tej is like, bro, I saw you 2 days back. And I was like, huh? And in my head I was like, oh, he must have seen me. Yeah, I sat next to you, bro. And he was like, bro, I saw you 2 days back. And I was like, in my head I was like, okay, he must have seen me outside, maybe going to the gym or something. I don't know. And he said, on YouTube, bro. I was like, what the fuck? This was something I was not mentally prepared for. Like I didn't see this coming, and like I didn't expect this to come, because when I posted the link for the stream on my WhatsApp, I mean like I made sure like I posted, shared it with like only selected people, and well later I found out that somehow Tej's name was there in those selected lists. I don't know how the fuck that happened, but well, when God has to decide, like, let's fuck you, they will send you a Tej. So Tej is there telling this stuff, and like everyone is sitting in the class, and like I was not mentally prepared. I'm so embarrassed at that moment. In that moment, and they just like, hey, do you guys know this guy is doing live stream and something? I'm like, bro, what the fuck, bro? And he is doing this right before Hamish is about to deliver a lecture on differential geometry. Like, that's so evil, bro. That was like, and for the entire lecture I was so distracted, like, I couldn't make sense of a lot of things. Bro, Tej, you did some wrong shit, bro. Seating arrangement is one of the possible outcomes of PNC. Bro, I mean like there's no sitting arrangement. It's just, yeah, I get it. Literally the lecture you were discussing right now. Yeah, bro, I literally spent like 3-4 hours in the library today to make sense of this. By the way, Tej, were you able to make sense of what I was saying? Well, you are my peer, so you would know better. But I tried a lot, but this is so hard just to like, fuck man, differential geometry. This is so hard to explain. Well, fuck explain. This is so hard to understand itself. And I explain it with the slides. I joined not that long ago. Then, bro, you didn't miss much. Fuck. Oh. Well, I just covered this one, this slide. Oh. Yeah, like differential geometry occurs in the parameter domain. but I got the parameter in the spatial domain. Okay. Okay, good. I hope any point, any criticism, like I'm pretty sure I'm saying a lot of bunch of wrong shit somewhere. If you find, but I got, if you see me saying something wrong, let me know, bro. Oh, and we don't have the slides for. I guess I'll have to stop right at this point because I don't have the slides. Perfect revision for me, but bro, that's the idea. That's the idea. That's the idea. I wish I had that some sort of tablet. Then I could have just. How's the coursework going, bro? Oh, I'm doing that quaternion proof of that associative property. So you know how it's going. You know how it's going. It sucks, bro. It sucks so much. But I have to start like this programming ones. Yes, trailer will be released later, bro. And like the thing that I wanted to discuss, how to define a surface, and like that too is like a heavy mathematical stuff, and that is also like just the how do I say, foundations to create something even much worse, a more evil piece of mathematics. Is there something else that I can do today? I don't know. No, bro. Slides. No, I don't think so. I mean, like, I really wanted to cover the differential geometry for the surfaces, but there are no slides. And I don't think I can write with mouse anymore. Nah, there are so many mathematical elements in that I can't write it with a mouse. No. Well, I guess I will call it a day. I think, yeah, it's fine. Maybe I'll figure out something for writing mathematics. Either that or I'll just switch to programming from next weekend. What can I say? जिम कर रही है, हाँ भाई, बहुत जिम कर रखी है, बहुत जिम कर रखी है, इतनी जिम कर रखी है बस वाले को ठोक दिया मैंने। बस वाला जा रहा था कि हट नहीं रहा था, मैं कहा हट जाओ, जो जिम कर रखी है, ठोक दिया मैंने उसको। By the way, I was running on treadmill yesterday. I ran like 30 minutes on a treadmill, and then it has some sort of what's the word I'm looking for? I mean, like some sort of function that like after 30 minutes it just stops, and like after 30 minutes it just came to a stop, and like I couldn't get it running back again. Like people tried to start it again, and like it was fucked for some reason. And I pretended like I don't know shit, bro. But yeah, broke a treadmill. I ran so much that I broke a treadmill. Yeah, that's what I'm gonna write on my CV. Yeah, I broke treadmills, bro. Yeah, I guess that's pretty much it. I guess bye bye. See you guys next time. Maybe I'll do programming that might be more interesting. I mean, like, I won't do the coursework. I would just do something else because otherwise, Tej is watching my stream. He would just copy my solution. No, he won't do it. Uh, there's a risk of collusion, so what can I say? But I can do one thing, right? After submitting the assignments, I can discuss them like when it's way past the deadline. Then I can discuss the programming assignments. I think that's more sensible. I don't know. But yeah, if I decide to do the programming as some programming related stuff next weekend, then I will just write some graphic stuff. Well, I want to actually go through that learn OpenGL tutorial. I mean, like, I did learn OpenGL from another source, but I have been told by a lot of people that learn OpenGL is a very good source. You should follow that one at least once. I'm gonna do that. I'm gonna do that live. I'm gonna basically learn from that and implement it live. But yeah, that would be a nice idea. I mean, like, I want to do more of this differential geometry, but it's so hard to do with the mouse. It makes no fucking sense. Review on Black Myth Wukong, bro. I don't know, bro. It looks good. I haven't played it. Yeah. But when are you sending me the Black Myth Wukong, bro? I asked you. Send it to me or bad shit will happen to you, bro. Send it to me. Okay, do one thing. After the stream ends, like, go buy Black Myth and send it to me, and you will get a girlfriend within 2 days. Like, that's like that's my blessing. Good night, bro. See you guys on the next weekend.